let's actually change this. Instead of returning a function, this nested function is actually going to be called. So in our example over here, we can actually, instead of returning this function that we've declared here, we can actually call the function and then return. So tell me, how does this differ now? Now that our create hello world is not returning a function, we're actually calling the function and returning the value. So now this, instead of being a function, is just going to be the string hello world. Now, continuing with the article over here, they pretty much just review some things that I talked about. We can declare functions inside of other functions. There's another concept of function hoisting. What that essentially means is that we can create a function like add, taking two values, a and b, and just returning them, like returning the sum of them. Okay, so back to the editorial, we can go ahead and continue to finally the important topic of the day, closures, which to be honest isn't super related to hello world, but let's continue. What closure means is that functions in JavaScript have access to variables outside of their scope. So going back to our IDE for a second, we have a function that adds two variables, a and b, and console logs them. This can actually do more than that, though. If I declare some variable here, const c is equal to 10, I can not only add, well, here we're not really adding, we're just printing them, but a plus b plus c. This function has access to c, even though it's outside of the scope. Now, if we run this, well, we're not doing anything, so let's call add 1 plus 2, but you'll see the output is not 3, it's 13, because we do have access to c. You can see they have their own example here, where they have an outer function, create adder, which takes a parameter a, an inner function f, which takes a parameter b, but this inner function actually also has access to a, even though it's outside of the scope. So it can add them together. When JavaScript was first created, it didn't support classes. So what people would do is they would get around that by using factory functions. So I'm going to create a function called create counter, which is not going to return a value. It's going to return an object. The only field is going to be a value, which is initially going to be 0. We're going to have a function which increments it called increment plus plus, and then return the value. Well, let's return it in the same line after we have incremented it. So now, and let's fix the typo. This is our function, but we're not returning an object. It's not doing anything. Yes, this has scope. Yes, this function can access this value and increment it, but it's not doing anything now. This create counter can't really return the object until we actually return it. With JavaScript syntax, we can create an object like this. And the only thing we need to expose externally is the increment method. So we're going to say increment is going to be set to our increment method that we defined up here. So now when we use this create counter and call it, we're going to create a couple counters, one counter 1 and counter 2. Now each of these counters is an object. For each of them, let's start incrementing their values. Let's say console.log counter 1.increment. And let's do it again. And let's do it also for counter 2 and see what happens. Okay, we got 1, 2, 1. That's pretty much what we would expect because we want each counter to have its own value. But how does that work? How is JavaScript doing that? Yeah, closure tells us this has access to the value variable. But every time this function is called, we're creating a new value variable. So each increment will get access to its own copy of a value. And when we return this, we are exposing access to the increment function. So this is hidden state, right? Closure is all about hidden state. And hidden state, of course, can be used for object-oriented programming. It's pretty useful for that. So I really wanted to illustrate this because I think this is a really important example of closure. Okay, so back to the editorial. Let's continue. We can see they're talking about arrow syntax, which I pretty much already covered. And I also covered that it does not support function hoisting. I guess one thing I didn't talk about is that we can omit the return value. We know that with anonymous functions, like up here, right? Closure is all about hidden state. And hidden state, of course, can be used for object-oriented programming. It's pretty useful for that. So I really wanted to illustrate this because I think this is a really important example of closure. Okay, so back to the editorial. Let's continue. We can see they're talking about arrow syntax, which I pretty much already covered. And I also covered that it does not support function hoisting. I guess one thing I didn't talk about is that we can omit the return value. We know that with anonymous functions, like up here, we're given a couple parameters, and then the block of the function, we can do some stuff here and then return a value. But if we have a really simple function that's just adding two values together, we don't actually have to put that return statement explicitly. So this is an anonymous function taking two parameters, adding them together. And here, since we don't have those curly braces around our block function, that tells us that this will immediately be returned. And it's just a single line. If you want to omit the return, you can only have a single line function. So now let's go ahead and continue. They briefly talk about the differences between function and arrow syntax. Now, lastly, let's get into what these ... dots mean over here. This is called the spread operator. Basically, let's say I have two arrays like this, A and B, and I want to combine them together. I can do that like this. I can create a new array like this, take all the values from A and add them to this array. And I can do that with a spread operator. It basically expands every value in an iterable like an array. So we can do this. That's the first value of the array. And the second value of the array is going to be ... B. But this array will not have two values because we're actually going to expand everything from each array. And then we're going to go ahead and print it. And then taking a look at the output, we can see we get what we would expect. Now, if I declare a function like add, and I want to be given an iterable like args, I can access the values that are given in this by using the index. So I can say args at index 0 plus args at index 1, and then return that value, or rather just console.log it. Hey everyone, welcome back, and let's write some more neat code. Code today. So today, let's solve LeetCode 2620 counter. And by the way, this is day 2 of LeetCode's JavaScript challenge. I think more and more companies are asking these types of questions, especially to front-end devs. So I highly recommend checking these out. We are given an integer n and we want to return a counter function. The counter function should initially return n and then returns one more every time it's called. So on the first call, it should return n, next call, it should return n plus 1, etc., etc. Well, there's not much for us to visualize here, so let's go ahead and actually jump into the code now. Okay, so now let's get into the code. We do have some boilerplate here, but before we get into the code itself, I want to show you how it's actually going to be used. So down here, we have a create counter. That create counter is obviously defined up here. It's a function, as you can see, but it actually returns another function, and that's what we're going to be implementing. Once that counter is created, remember, it's a function, not just a value. So we're actually going to call this counter, even though it's a variable, it's a function. We can call it, and it's going to return 10 because 10 was the value passed in. We call it again, it'll return 11, then 12, etc., etc. So this is pretty weird if you've never used JavaScript before, because this sounds like object-oriented programming, but JavaScript originally didn't support that, so people used functions and closure to get around it. What closure means is that this inner function has access to variables defined outside of it. We don't have to declare like a count in here and set it to n or whatever the value is passed in. We can just reuse the value defined outside here. What that means is we can do basically just this, return n plus plus. So what that's going to do is increment n, but before it increments n, it's actually going to return n. So it's going to return 10 and then increment it. So the value n will be set to 11, but the value that's returned is going to be 10. The next time we call it, it's going to do the same thing. The value is currently 11, and that's what's going to be returned, and then the value is going to be incremented again. Basically, n is sort of a hidden state, right? It was only passed in once, right? We only passed 10 in here, but somehow that value still exists somewhere, and we can't find it. We can't access it. It's there. We just can't access it. Pretty much like objects with like private variables. So now let me just run this to show you that it works. And as you can see, yes, it does, but I'm going to continue with this example because to make it even more obvious that we're doing object-oriented programming here, and I'm surprised that it passed even though I had this uncommented, so let me just comment that again. But to make it look even more like object-oriented programming, pretty much from our previous video for day one, what we had was we declared a variable like the count and set it equal to n. And then from here, we can just go ahead and return the count. But of course, here we're missing the incrementation. So we should basically just do count plus plus. So this looks more like object-oriented programming from other languages, and I'll run this as well. And this also works. And to go even further beyond, let's actually translate this code into a class because ES6 JavaScript, I think it came out in like 2015, did add support for classes. So let's create a class calling it counter. And so now more traditionally, we can actually create a constructor with the keyword constructor. Let's say it takes in the same value n, pretty much like the outer function did out here. And just like above, this variable, of course, will not go out of scope. Well, normally it actually will, but we can make a member variable for it with the this keyword. This n is going to be equal to n. So now we pretty much have what we did up above here. I guess I could name this count. Well, I'll leave it as is. Nobody really cares. Now let's just define an increment method, which, yeah, you don't need the function keyword in a class to do that. I know it's kind of weird, but yeah, when you're dealing with classes, you actually don't need function keyword. So let's create that increment method. What's it going to do? Probably just return this.n. We could do plus plus, but this way it will return the original value, or we could add this plus plus to the beginning to increment it before returning. I'm going to leave it at the end though. And now I'm going to create a counter with the counter constructor that we have up above, passing in, let's say 10 again. And then I'm just going to call counter.increment. And what this will do is it'll log 10, I believe, the first time. I guess it's not really incrementing the value. So maybe we could have moved this to the beginning. Actually, let's do that. Let's move that to the beginning just to illustrate it. Prefix incrementing will increment this before returning. So if it was given a 10, we will increment it and then return an 11. And we can do this many more times, just like down here. I know we pretty much talked about this in day one's video. I didn't realize that they were going to be doing this in day two. I would have saved it for this video if I knew. But if you found this helpful, please like and subscribe. If you're preparing for coding interviews, check out neetcode.io. It has a ton of free resources to help you prepare. Thanks for watching, and hopefully I'll see you pretty soon.
Meet CodeRabbit.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve LeetCode. Hey everyone, welcome back and let's write some more neat code today. So today let's solve day 3 of LeetCode's JavaScript challenge. We are today solving counter 2. Yesterday we did solve counter 1, so this is going to be a bit more in depth. We want to create a function that creates
फिर क्या करूँगा बताओ हाँ एक मिनट लड़की
Hey everyone, welcome back and let's write some more to the code. So this is the boilerplate that they give us, and you can see, yes, it is a function, and this function is supposed to return an object. And normally in JavaScript, we want to do that with closure. Now, what we could do with this initial count is create a member variable like an init count. Well, I don't think we can actually reuse the name in JavaScript here, since there really isn't a this keyword, like we couldn't distinguish between either of these. So we have to name it something different. So I'll just say init count, and that could be set to the initial count here. But we actually don't even need to do that because this variable, as far as the inside of this function is concerned, this will never go out of scope because of closure in JavaScript. Anything that we define in here, any of the methods we define, increment or decrement or resetting, they will all have access to the initial count, and they'll all have access to the shared copy of that initial count every time we create a new object. But for us to do that, we have to define these methods, which is the easy part, and then expose them as well. What do we mean by exposing them? Well, when this function is called, it's supposed to return an object. You can see that down here, create counter, and then we get a counter, and then we can call increment, reset, and decrement. So after this function is called, we should return an object, and this is how we create objects in JavaScript with curly braces, or at least that's one way to do it. And it doesn't look like we actually need to expose the value itself in it. So we won't be returning that. We'll just be returning the increment, which will be assigned to increment like this, and do the same for decrement as well as resetting. So each of these is assigned to the methods we've defined up here, but we haven't quite defined them just yet. We're going to do that with the function keyword. That's one way to do it, just like we kind of have up here. We have a function out here, and then we have a function inside here, which is called increment. And this function will have access to that init value that was passed in. Increment itself doesn't take a parameter, but it will be updating what our current count is. We should probably create another variable for the count, because remember, we need to be able to reset the counter. So we need to know the current count, but we also need to keep in memory the initial count. So I'm going to initially set the count to init, increment the count, and return it. And I'm going to do that like this by incrementing it before we return it, prefix incrementation. We can do the same thing with decrementing. So return decrement and then return the count. And also don't forget to add the function keyword here, and do the same thing with resetting the count. Well, actually not the exact same. We are going to return the count here, but before we return the count, let's actually assign the count to the initial value, which remember, it never goes out of scope. Even though we don't have it like assigned to a member variable over here, it was passed in. And because of closure, these functions will always have access to that value. This is the hidden state of our counter. Well, I guess our current count is also hidden state. But now let's go ahead and run this to make sure that it works. And as you can see, yes, it does. And it's pretty efficient. Well, these are pretty constant time algorithms, so we won't pay too much attention to the distribution here. But that's one way to solve this problem. I'll quickly go over a few more ways. We know that JavaScript also supports classes. So we could also similarly solve this problem with a class, just like this, by defining the class counter. creating the constructor more explicitly, same parameter. Piloting is going crazy, but more than just the initial count, we also constructors, we do not have that same closure. This will go out of scope. Like if we define some more methods down here, but yeah, it's pretty weird. Member variable that equal to this dot initial count, and I don't know if we actually need to return this or not, but let's go ahead and do it. And this is pretty equivalent to what we have. Have up above with the function solution, with the factory function, which is returning an object. It's pretty much just two different ways to do this. Now, if we do want to make this first solution a little bit more concise, we actually can. Here, JavaScript supports a shortcut where if you have a key assigned to a value in an object and the key and the value have the exact same name, as a shorthand, you can omit the value and omit like that colon here and just have it written like this. So I can do that with the other two as well. And this makes it just a bit more concise and sometimes readable or sometimes confusing if you're a beginner. And also, we don't have to define functions with the function keyword. We can actually create arrow functions just like this, where we have the parameters, which we don't actually have any parameters, but that arrow here will lead to some curly braces, and this whole thing will be assigned without the function keyword to a variable, which I'm going to call increment, and just like that, we have the same exact function defined up here that we did before. This is just another way to do what we have down here. I could replace the rest of these, but you probably know how to do it, so I'll let you do that if you want to. And honestly, you could even define this inline function down here, well, this anonymous function down here, to make this an inline. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, apply transform over each element in array. This is the first time I'm doing a LeetCode problem without drawing anything, so let's see how it goes. But we're given an integer each element in array. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, apply transform over each element in array. This is the first time I'm doing a LeetCode problem without drawing anything, so let's see how it goes. But we're given an integer array and a mapping function. We just want to return a new array with the transform applied. This is how we can call the function. And they tell us to please solve it without array.map. Well, I'm not going to listen to them because we can solve this problem just by saying return array.map every value using this function. and then return the result. We can go ahead and press submit and we pass. So what exactly did that just do? Well, it just happens that map is a function that's called exactly like this. Well, map isn't called like this, but map accepts a function as a parameter and it will apply that parameter, which is a function. It'll apply that function to each element in the array. Notice how map is a method of the array object. And the reason these two parameters are passed in is just to pass in all the information of each element in the array, which happens to be the value and the index. Now, I want to mention that if you're not familiar with something like this, that map is a concept from functional programming. Of course, we could actually solve this problem with a loop, and I'm going to do exactly that. But functional programming is a little bit different from procedural programming, which, to be honest, JavaScript kind of supports both of those. It's kind of in between functional and procedural, because notice how this map, it accepts every value from here, but it doesn't have any state associated with it. That's kind of an idea about functional programming, that there is no state. So this is another way of programming. You can actually get very far without having any state, which means not having any variables. If you've ever used like a real functional programming language before and been forced to do that, you can get pretty far by passing functions into functions, and especially with recursion. But another way we could solve this problem is just by iterating over every value in the array. You can actually do that like this. So for const n of the array, I know we use the keyword of instead of in like we do in Python. Trust me, that bothers me too, because of what this will do is for the array, it will iterate over every value in the array. N will be equal to the value. But if we say for n in the array, we get something different. For this array, we actually get the index. That always trips me up, no matter how long I do this. But in our case, we know this function is going to be called not only on the value, but also on the index. So we probably should iterate like this for I in the array, because this is going to be the index now. So we're going to call the function just like we were told to by passing in the element array at index I and the index itself. We want to actually use this value and then ultimately return it in the form of an array. So what I'm going to do here is const the result is going to initially be an empty array. Well, why did I use the keyword const if we're going to be updating this? Because const just means that we can't reassign result now. We can't reassign it to 1 to something else. We can't reassign this variable. We can modify it. Remember, result is an object. Of course, we're allowed to call methods on it, like pushing a value. So that's an important concept to know. Now, we could have also declared this using the let keyword so that this will behave as a block scope value, but I usually just use const. And then here, when we get that value, we can go ahead and just say result.push, which is how you append to the end of an array in JavaScript. And then we can return the result, and then I'll run it to make sure that it works. And it looks like we got the wrong answer. So what went wrong here? Well, I'll pretty much just tell you. The reason we can say const I in array is because this array is not just an array. It's not a primitive type. This is an object, believe it or not. And the in keyword, what it will do is it'll take an object, suppose like this one, where maybe one of the keys happens to be a string, like name, and then the value happens to be an integer, like 7. And then we have another key, like, and then we can return the result, and then I'll run it to make sure that it works. And it looks like we got the wrong answer. So what went wrong here? Well, I'll pretty much just tell you. The reason we can say const I in array is because this array is not just an array. It's not a primitive type. This is an object, believe it or not. And the in keyword, what it will do is it'll take an object, suppose like this one, where maybe one of the keys happens to be a string, like name, and then the value happens to be an integer, like 7. And then we have another key, like this, that's also a string, hello, and then maybe the value is a string like this. This is an object. If we try to iterate over it with the in keyword, it'll go through every single key. And the key for objects, in this case, is a string. And that's also the case for the index of the array. This is not an integer, it's actually a string, and this function was expecting an integer. And if we were using TypeScript, this would be caught at compile time, not runtime. So that's why most people, I think, use TypeScript over JavaScript, but we're just talking about the fundamentals here, which are similar in both languages. So what should we do at this point? If we know I is a string, but it should be a number, we're going to cast it into a number. So just like this. In JavaScript, there isn't really a concept of integers and decimals. It's pretty much all just numbers. So now we're going to try to rerun this code and see what happens. And now, as you can see, it does work. Now, one last thing I wanted to quickly mention is that passing a function into another function is actually an example of the strategy design pattern. It allows us to augment the behavior of an object or a class. Usually this is talked about when we're talking about object-oriented programming, but I think it also applies to like functional programming and procedural programming, because what we're doing here is giving ourselves the flexibility to modify the behavior of this function without changing a single line of code. Because what we did is we gave ourselves the flexibility to pass in a function here. We might decide to pass in a function that doubles every value in the array, or maybe triples it. We can change our minds later. We can pass in a different function. We can use this in a very general way. That's the purpose behind the map function as well over here. And that's also kind of the power behind functional programming. Also, that this strategy design pattern happens to be an instance of the open-closed principle, where this code is closed to change, but it's open for extension. We can extend what this can do just by passing in a different function. If you're interested to learn more, I talked about that in this video. I'll link it below. But thank you so much for watching. If you found this helpful, please like and subscribe. If you're preparing for coding interviews, check out neetcode.io. It has a ton of free resources to help you prepare. Thanks, and I'll see you soon.
What science says about procrastination? Creating to-do list is not going to help you. Installing Pomodoro app is
Hey, everyone. Welcome back, and let's write some more neat code today. So today let's solve the problem, filter elements from array. I believe this is day 5 of the JavaScript challenge. It's a pretty similar problem to yesterday. We're given an array. It's a pretty similar problem to yesterday, but I'm going to go through a couple important details about JavaScript as a language, just because we have the time. We're given an integer array and a filtering function, and we want to return a new array with fewer or equal number of elements. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, filter elements from array. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, filter element. Hey everyone, welcome.
Hey you, we're live right now.
That's right, we're currently broadcasting live another episode of the Android
Hey everyone, welcome back. Are similar in both languages. So what should we do at this point? If we, in JavaScript, another function is actually an example of the strategy design pattern. It allows us to. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, filter elements from array. I believe this is day 5 of the JavaScript challenge. It's a pretty similar problem to yesterday. We're given an array. It's a pretty similar problem to yesterday, but I'm going to go through a couple important details about JavaScript as a language, just because we have the time. We're given an integer array and a filtering function, and we want to return a new array with fewer or equal number of elements. If you're not familiar with filtering functions, this last sentence might confuse you. What do they mean by a new array with fewer or equal number of elements? Well, think about what filtering is going to do. Take a look at this example down here. We have an array with 4 elements, 0, 10, 20, and 30. We have a filter function that checks if a value is greater than 10. If it's greater than 10, it looks like we're returning true. If it's not greater than 10, we are returning false. So as you might guess, this function is going to look at each element and determine if it's greater than 10. And for the ones that are greater than 10, we're going to create a new array with those elements. 0 is not greater than 10, neither is 10, but 20 and 30 are, so that's what we get in the output. So that kind of satisfies the requirement of fewer or equal number of elements. That's kind of what filtering does by definition. And in terms of coding it up on the right over here, all we have to do is just take this array. Every array has a method, just like every array has a method map, which can take each value and map it to a new value. It also has the method filter, where it will do exactly what we talked about earlier. Now, it has to be provided some function, because how exactly are we going to filter these? Like, what exactly is the criteria? If we wanted to recreate the greater than 10 function that we were given in example 1, we could do so with a lambda function or an inline anonymous function like this, where the parameter is going to be, just like they told us over here, the array value and the index. So here I'm going to just create a couple variables for those. I'm going to call it n, and I'm going to call the second one I. N is going to be the value, I is going to be the index. We don't have to pass these in. Remember, we're just creating a function here that we're passing into the filter function, and then this function will be called underneath the hood. This is kind of an example of declarative programming, because we are not explicitly writing this out. This is sort of functional programming. If we were to do it the opposite way, which I'm going to do later on, that is going to be an example of imperative programming, and I'll show you that in just a second. But for now, let's finish up this function. How do we decide what to return? Well, to create a function, let's create our curly braces and then define the function, just kind of like they did over here. I'm just going to go ahead and copy that. Return n is greater than 10. So this will obviously not pass the problem, because we're not doing what they told us to do, because it's pretty much a trivial problem to solve. But this is an example of filtering. And if you want to get even more fancy, you can get rid of these braces, these curly braces, and get rid of the return statement, because this anonymous function is just a single liner and it's returning the value anyway. Let's get rid of the semicolon as well. And this is equivalent to the previous code that we had. But now let's actually solve the problem. I'm going to, instead of passing in the function we defined, I'm going to pass in fn, the function they passed into us, and I'm going to return this and then run it to make sure that it works. And as you can see, yes, it does. The only problem is they told us we're not allowed to use a built-in filter method. So let's solve this the imperative programming way, where we actually explicitly write out the steps. We manage our own state. So I'm going to first build the new output array. Well, initially it's going to be an empty array result. And then I'm going to go through every single element n in the input array. But remember, in is not the keyword you use to access the value of a data structure, whether it's a object or an array. If we want the values, we use the keyword of. Now, with each of these values, we just want to apply the filter and then decide whether we should add it to the result or not. So easiest way to do that is with an if statement, right? Let's call fn on the n value as well as the index. But then we realize we actually don't have the index. So we remember, to get the index from an array, we actually do have to use the keyword in. So good that we are reviewing these concepts. So now I'm going to change this to I, because it's the index. So now we can pass the index in, but how do we get the actual value in? Well, we can do that by array at index I. And we reviewed last time that this is actually a string when you iterate through it like this. So we can cast it to a number, and then we can finish up our if statement here. If this evaluates to true, then we want to, our result, push the value array at index I. And then after that, we just need to return our result. I'm going to comment this out and then run the below code to prove that it works. And as you can see, yes, it does, but it is quite a bit slower. That's mostly, I think, because we are creating a new dynamic array and potentially resizing it many, many times. Array filter will actually update the array in place, but we are not allowed to do that. So we can go with this approach. Very quickly, I think it's also worth mentioning that we could and probably should iterate through this just with a pointer index I, because having to convert a string to a number can be error prone and you might not remember to do that. It can cause bugs sometimes. So usually it's better to actually iterate through arrays like this, array.length, and then I++. So this syntax is pretty similar to most languages, except of course Python. So what we're doing here is declaring a variable with the let keyword. We can't use the const keyword because we are going to have to increment this pointer I. So I'm going to use the let keyword, and we're going to keep going until we're in bounds of the array and increment on each iteration of the loop. So initially we start at index 0, and we do not have to convert this to a number now, though I think it would technically work if we did. But let's run this code now and see if it works. And as you can see, yes, it does. Now, lastly, I want to take a couple minutes to quickly skim through the editorial because I think there are a couple nuggets of knowledge in here that we didn't really have to learn about in the problem, which kind of makes me wonder why they include this in the editorial, but oh well. One is that JavaScript has this concept of truthy and falsy values, and many languages do, including Python. The idea is that when you write if statements, we know that the statement is evaluated based on whether it is a true or whether it is a false, but actually non-Boolean values such as integers like 0 can also be used in if statements. What would this execute? This would be false. 0 is false. What about an empty string? Well, usually that's false. If we were doing this in Python, we would also get the same result. And they list a bunch of other things that are considered falsy, which one is the false value itself, the number 0, the number -0, not a number, which usually happens when you try to divide by 0, an empty string, a null value, and the undefined value. Undefined is a bit special in JavaScript. Most languages don't really have this concept. The idea is that when I declare a variable, such as const n is going to initially be equal to null, n is explicitly set to null. But what happens if I actually don't set n to anything? What's this going to be? It's going to be undefined because we never assigned it. That's the distinction between null and undefined. Null you have to be explicit about, but undefined is pretty much always going to be there. You can't really avoid running into undefined values in JavaScript. Even in TypeScript, you sometimes can't avoid that. Now, they do mention here that sometimes it can be dangerous. Like this if statement over here, if user input isn't null and it isn't an empty string, then do some operation, which can be shortened to this statement below. But that could be dangerous because what if user input is the value 0 up here, like the integer 0? Then what would happen? Then this if statement would not execute. But do we want it to execute? Perhaps we do. In that case, it's worth being explicit like this. It's worth being explicit to check if a value is actually not equal to null. Maybe we are allowed to use 0. We're just not allowed to use null or an empty string. Sometimes you find me writing stuff out like this in LeetCode problems just because I don't want to confuse myself. There's also this concept in JavaScript that the conditional operators can actually be used for assignment. What this is doing here is if the text input variable evaluates to false, then the string value will be assigned to what comes after the or conditional here. In many languages, this is not the case. I don't believe this would happen in Java or C++. You would probably get a type error because you're not allowed to use a string in a or condition. But in Python, this actually does work. Just to quickly prove it to you, I'm going to write print false or some string like hello. So what will happen with this? Will this print false? Will this print true? Because shouldn't this evaluate to a truthy value? So technically this condition should evaluate to true, but actually it doesn't. As you're about to see when I run this code, we actually get an output of hello because the first part of the condition evaluates to false. So the rest of the condition is what is actually returned here. So we could even assign this to a variable over here in Python. Let's say just n for no reason. And then when we print the n value, we'll kind of get the same thing. We'll get hello. But now if I try to use that same n value in a conditional down here and then try to print something, maybe I'm going to print world now, you'll see that this time the n value is going to do something different. The n value here evaluates to true because even though the value here is assigned to a string in the presence of an if, this will turn into a conditional true or false, a Boolean value actually. So I know this is Python, but actually JavaScript operates the same way. I just wanted to show you a different language. And another thing that's worth knowing is the nullish coalescing operator in JavaScript. This is pretty handy dandy in many cases because it operates similarly to this thing over here, where if this part evaluates to false, everything else is what's returned. So down on the right over here, if I do an assignment, n is going to be equal to some empty string, but if that empty string is falsy, then do everything after, then assign it to what comes after the string, which might be hello. So if this evaluates to false, then the double question mark will execute the rest of this part of the code and then assign it to this variable. So that's just kind of a shorthand way of maybe even writing out a ternary operator. Like this would be equivalent to if I wrote down here const n is equal to empty string, but if that is equal to empty string, if empty string is true, otherwise we are going to assign this to hello. I believe these two lines of code are equivalent. If this is true, it'll be assigned to n. If it's not, it'll be assigned to hello. Now, skimming through the rest of this article, I don't believe there's anything crazy that we haven't talked about yet. I think the rest of these solutions we covered last time. So I will close things off by mentioning that JavaScript is a weakly typed language. They mentioned that also in this editorial, but I'm sure they're going to talk about it more in the future JavaScript challenges. So that's where I will leave things. But Python, if you're familiar with it, is not quite a weakly typed language. It's sort of a strongly typed language, though it's not like the strongest. But this is just a bit of food for thought if you're interested in researching something else. I'll probably cover these concepts in future videos if you're interested. So definitely
we can mention that in the dot product. Yeah, no, we can mention. I know that this is there.
Definitely subscribe if you want more. Thanks for watching, and I'll see you. Hey everyone, welcome back, and let's write some more neat code today. So today, let's solve the problem array reduce trans. transformation. So we already talked about mapping and filtering, but there's also another common function when it comes to functional programming, and that is reducing. Conceptually, it's similar to the other transformations, but in terms of using it, it's a bit more complicated. So that's what I'm going to be spending my time on in this problem. First of all, what even is reducing? Well, it's all about aggregation. Let me actually show you what reducing is about. Let's say we're given this array and we want to find the sum of it. Well, it's pretty easy to just pass this into like a library function and get the sum, but I want to show you how we can do that with the reduce function that is built into arrays in JavaScript. So we can say nums.reduce this array, but we have to actually tell it how we want to reduce the array, how we want to aggregate this, because aggregation can work in many ways. We could be trying to find the total sum of this array, or we could be trying to find the maximum value of this array. The common theme here, though, is that we're given a list of values, but we want to reduce them to a single value. Makes sense, doesn't it? Now, the function that we pass in to reduce has to kind of follow this header where it takes two parameters. The first parameter is our initial value, and the second parameter is going to represent a individual value from our list. So what I mean here is when we take the sum of an array like this, what do we want our initial value to be? Probably 0, right? So that's how we're going to call this function when we actually do pass it into reduce. So let me actually do exactly that. I'm going to pass in this function into reduce, but we also have to pass in a second parameter to reduce to tell it what we want our initial starting value to be. When we calculate the sum of this, I'm going to initially set the starting value to 0. Now, to actually fill in this function, you might be getting the idea here. This is going to be the initial value. So what would we want to return if we're trying to take the total sum? We probably can take the initial value and add it with n and then return that. So what that would do for the first value is obviously 0 plus 1, and that's what it would return for just the first value here. But then on the second iteration of the loop, this is where something cool happens. This function is going to be called again, but it's not going to be passed a 0 for the initial value. It's going to be passed in the previous value that we calculated, which was 1. And if you take that 1 and add it with our current value n, which is going to be 2, we get a 3. So then we would return 3 from here. Next, we get to a 7. So we take 7 and add it with the previous value that we just calculated, which was 3. So that's how this function is going to work. But notice how most of that is abstracted for us. That's kind of the power behind functional programming. We don't have to manage our own state. We don't have to iterate through this list. And just to prove to you that this works, let me go ahead and console log it. And as you can see, the result is 19 as we would expect. So now that we know a little bit about reduce, let's actually solve the problem. So the most trivial way to solve this problem is just to take the list of nums, call reduce on them, passing in whatever function we are given, because that's how we want to reduce this with this initial value. So basically that's what they were trying to teach us, how reduce works, even though they told us we're not allowed to use it. But don't worry, I'll solve it the imperative programming way in just a second. Let's run this to make sure that it works. It does, but there are other solutions to solve this problem. So let's take a look. Let's recreate what this is actually doing explicitly. We know initially our result is going to be whatever that initial value happens to be passed in. And then we know we want to go through every single number in the input array nums. Take a second to think how you iterate through each number in an array. Well, in Python, we can use the keyword of. That's usually the easiest way. So for const n of nums, in this case, we don't need the index, so we don't need the keyword in. And with each value, we just want to call that function. And depending on which aggregation we're doing, we could honestly pass in n and the initial value in either order. But technically, the correct order to pass it in is to pass in the initial value first, and then pass in the current value that we're at in our list. And then we would call this function and then update our result with that value. But notice there is a small bug here. When we call the function, we don't want to pass in the initial value every single time. I know that's a bit misleading because based on this over here on the left, it kind of seems like we do. But let's say the initial value is 0. We don't want to keep adding 0 with each element in the array. We want to add the previous result, which is over here, thankfully stored in a variable, and add that with n. So I'm going to pass in the result into this function, which initially is the initial value. So it does work out for us. After that's done, I'm going to go ahead and return the result and run this to make sure that it works. As you can see, yes, it does. But there's one last quick solution. It's kind of a halfway solution between this reducing functional programming solution and this like fully imperative solution. I guess not entirely imperative because we could have actually iterated through this with an index that we like explicitly increment, but I'm sure you already know how to do that, so I won't bother with it too much. The other way to solve this problem would be to take, let me erase this, that list of nums, and there's another function that belongs to every list. It's called for each, and basically it'll call some function that we pass into it on each element in the array. So how can this be used to solve this problem? Well, first, let's pass in a function. I'm going to pass in an anonymous function, which we can do just like this. We have our parameters here. Which parameter are we passing in? Well, we're going to go through each number. So I'm going to have n for each number in the input. And this is our block. What do we want to return? Well, in this case, we don't really need to return anything. We just need to update our outside state. We need to update our result value by setting it equal to the function being called with the result and the individual value that we're currently at. After running this, our result variable will be updated. So we can go ahead and run this to make sure that it works. And as you can see, yes, it does, but I guess it's a little bit slower. Those are all the solutions I wanted to discuss. You might be starting to see the power of functional programming, or maybe you're starting to hate it. I don't know. But thanks for watching. If you found this helpful, please like and subscribe, and hopefully I'll see you pretty soon. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem function composition, day 7 of the JavaScript challenge. We're given an array of functions and we want to return a new function that's already defined for us over here on the right, but we just need to add the implementation of this function. Now in this series, we've already learned a lot about functional programming, and today we're going to continue. So here we're given a list of functions in our outer function, and we actually want to take this list of functions and apply them consecutively in this kind of manner. So this kind of looks very mathematical. Basically, these are the 3 functions, and we're also given some value x. I don't even know if it's an integer or something else. Well, I guess based on this example, it's an integer, but the way JavaScript works is there's no static typing. So who knows, like this could be some crazy stuff getting passed into us, but we're not really responsible for that. We are responsible for taking these functions and applying them in reverse order on that single value x that's going to be passed in to the inner function. First of all, this seems pretty abstract. So let's actually take a look at the example for us here on